1,000 Class II wells in operation within the United States. On average, those wells accept more than 2 billion gallons of water per day that is associated with oil and natural gas development. Clearly, without the delegation of this program to state regulatory bodies, the federal law would be virtually incapable of implementation. In 1983, U.S. EPA delegated primacy authority to Ohio to run the UIC program. As the host of the Oil and Gas Regulatory Program, the Ohio Department of Natural Resources received the authority to manage the Class II program. Under the primacy agreement, the ODNR issues UIC permits for Class II wells, but U.S. EPA sets the standard for construction, maintenance, and continuous monitoring of Class II wells. The Ohio UIC program is regularly audited by U.S. EPA and has undergone peer reviews conducted by the Groundwater Protection Council. In December 1984, the Ohio General Assembly, the 115th, enacted substitute House Bill 501 that set in place standards for the storage and disposal of brines, called at that time, formation saltwater or produced waters from oil and gas production wells. According to federal standards, produced waters are the combination of formation water and water that has been injected into the formation either for well stimulation purposes or secondary recovery processes. Produced water is generally ubiquitous in character. It represents a low toxicity but high volume waste stream and therefore is not classified as hazardous waste under the Federal Resource Conservation and Recovery Act. State Representative Robert E. Hagan was the lead sponsor of House Bill 501, which served as the Assembly's response to an authentic environmental problem. Up until then, produced waters were often captured and stored in evaporation pits. This practice led to widespread pollution of drinking water resources. House Bill 501 banned the use of evaporation pits, and justifiably so. It then required that all oil and gas related produced waters be disposed of using the best and most preferred method under the landmark federal laws. Class II injections that permanently impounds the waste stream back in the same formation it came from or deeper. Interesting enough, HB 501 at introduction contemplated a moratorium on oil and gas wells until the state of Ohio could actually certify that a sufficient number of UIC wells existed to manage the brine that was being then produced. 501 also set registration and reporting requirements for brine haulers. HB 501 led to large-scale cleanup of damage caused by oil field practices that existed at that time and was a much-needed environmental improvement. Except for a minor amount used by local governments for dust and ice control, it is the law of the state of Ohio that all oil and gas-related produced water must be disposed of using a Class II UIC well constructed to the federal standards. Since that time, the industry has built up a network of Class II wells along the breadth of eastern Ohio to service the needs of oil and gas producers who must comply with Ohio law. Currently, there are 181 Class II injection wells operating in Ohio, or 0.12% of the nation's total population of such wells. The Ohio wells accept about 1.303 million gallons of produced water per day, or less than 0.05% of the total nationwide volume. It is important to put the recent events in Mahoning County into context with the wider use and track record of Class II wells existing in Ohio. Lately in Mahoning County, there's been a series of localized seismicity that after reasonable analysis has generated concern that may be related to a recently installed UIC Class II well. We accept that these are rational concerns. The well in question is a deep injection well for which the total depth penetrates into the granite basement rock lying below the deepest sedimentary rock known as the Mount Simon Sandstone, a formation with sufficient porosity and permeability to serve as an effective disposal reservoir. Many Class I and Class II wells target the Mount Simon Formation. We acknowledge that the concerns may be related to a yet to be determined geologic anomaly, likely a minor slip-strike fault, which is two blocks moving against each other in opposite directions, lying within the crystalline basement rock. According to experts, in order for the injecting to cause a seismic event, a fault must already exist that has existing stress on it to the point that it's already near failure. The injectate alleviates pore pressure to, in effect, lubricate accelerate near failure fault and cause it to slip. Earthquakes are the abrupt movement of sections of the earth that release vibrational energy. They are the result of plate tectonics, and the fact that the crust of the earth is composed of pieces that move, bump, and generally cause stress upon one another. One way that the rock of these plates responds to stress is by cracking, faulting. These plates are everywhere, and earthquakes can happen anywhere. This is nature. Earthquakes are measured on the Richter scale, the logarithmic scale. That means each measurement is 10 times greater than the measurement preceding. Large earthquakes are rare but can cause massive damage. Small earthquakes are continuous but release insignificant energy. Quakes in the 4.0 to 4.9 range are considered light and occur somewhere nearly once an hour. Quakes in the range of 3.0 to 3.9 are considered minor and occur somewhere 15 times per hour. Quakes in the range of 2.0 to 2.9 are also minor and occur 2 per minute, and those less than 2.0 occur continually. Roughly 1.3 million 2 to 2.9 magnitude quakes happen every year around the world. The majority of quakes associated with the Mahoning County in the 2.0 to 2.9 range, experts say that several of them were not felt at the surface. Having said that, I do not minimize the concern Mahoning County citizens have at this event. I would no more want my home in Fairfield County, home of the discovered well in Clinton Sand, shaking any more than they do. That's why we supported the Kasich administration's decision to temporarily suspend operations at this well and other projects within a radius of this well. It was the correct and prudent course of action to ensure the safety and peace of mind of area residents. This is evidence of an effective regulatory agency. We also believe the situation in Youngstown is a rare and isolated event that should not cast doubt about the effectiveness or usage of Class 2 injection wells, which have been used safely and reliably as a disposal method for wastewater from oil and gas operations in the United States since the 1930s, and is the preferred method for oil field waste management under the Safe Drinking Water Act. Even so, there have been some statements made that serve only to confuse the situation and are designed to create fear and uncertainty with the oil and gas development process. Opponents of the oil and gas development have been quick and insistent to claim that the Mahoning County UIC well is related to hydraulic fracturing. The North Star UIC well was not hydraulically fractured. It is not a producing facility. The event is not related to the process of hydraulic fracturing. People who say otherwise are working to create fear using a broadly spoken term for a process that, to this day, the public has scant fundamental knowledge, even though it has been used in the oil field over 1.2 million times, and in Ohio, 80,000 times over a 60-year time frame. The North Star UIC well was constructed and operating in full compliance with permitting conditions. A geologic anomaly is at the root of this problem, not the well. We need experts to fully understand the specific problem, learn from it, and then adjust regulatory policy accordingly to avoid future problems. Opponents of oil and gas development have, in this case and elsewhere, stated that the industry is exempt from federal regulation. Again, this is an attempt to criticize the process in regard to this. Recall that the Safe Drinking Water Act sets standards for public water supplies, including establishment of the Underground Injection Control Program, a process that has the specific purpose to permanently dispose by impoundment of a waste in an appropriate underground reservoir. Hydraulic fracturing is a well completion procedure designed to induce permeability in a low-firm oil and gas reservoir by creating a fracture, a pathway through the targeted reservoir blocks to more readily allow the oil and gas to move through the reservoir and into the wellbore to then be lifted to the surface. With few exceptions, it is a one-time procedure.